All right, hello everybody. My name is Jeff FANNELI, Principal Architect with Cisco, 18 years at Cisco. And this talk's going to be a little bit different. If you've been coming and listening to some of the panel discussions here, the panel's me, and this is going to be more a little bit of a technical session. I do have slides. They're not so complicated, but if you would prefer to sit closer, I know we have 3 screens here, you might enjoy the session a little bit more, but you don't have to. But again, thanks for coming. So what I wanted to do today is talk about a technology and a solution, a type of solution that's very popular with our customers and in the industry right now. This is not going to be a product pitch for, come buy this Cisco product. We're going to focus on the technologies underneath, and hopefully you'll learn a little bit about those. And I'll make some reference examples to our product, but again, not a product discussion. And if it looks like it's going that direction, I apologize, but I'll do my best. So what we're going to talk about today is something called QUIC, and this is a protocol that is growing very fast in the standards organization. Essentially is the foundation for web browsing. Everybody knows HTTP and the standards for HTTP. This is a new standard, up and coming standard for web traffic. And I want to talk about today how we feel this can be used and should be used to help customers that are deploying remote access and what we refer to as zero trust networking or ZTNA solutions for their customers. So that's kind of the topic today, and we should definitely have time at the end if there's any questions. Again, if you would prefer to just chat with me after, the Cisco booth is, I think it's over there, and I'll be there the rest of the afternoon. So thanks again for coming, and we'll dive right in. So to begin, what is ZTNA, or as we say south of the border here, ZTNA, and why? So ZTNA stands for Zero Trust Network Access, and the concept here is to provide zero trust principles for network access. So when we go to the office and we get on the Wi-Fi, we are connected to the network and we can talk to anything on the network. This is the exact opposite of zero trust, right? There's no access control that's applied based upon your role or who you are in the organization. Maybe if you're an advanced organization, you're doing something. But the concept of providing zero trust network access for employees, especially when they are remote, is of course of growing importance to all of our customers. And at Cisco, I don't think we have a single customer in the US, Canada, or elsewhere that isn't looking to deploy some sort of zero trust network access solution to their employees. So why? Well, there's basically 3 foundational requirements here. The first, obviously, is zero trust. What zero trust means is least privileged access. So when I connect to a network, what's my job? Based upon my job role, I should only be able to access the very minimum number of applications, resources, or whatever that I should have access to based upon my role. Zero trust. Of course, we want the end user experience to be excellent. I'm fond of telling customers, end user experience isn't everything, but without it, the customer will never buy a solution, because if your users are unhappy, then they will refuse to use any type of solution or service. Now, most zero trust network access or ZTNA solutions are a SaaS delivered, so they're sold as a service, a cloud service. Not always, they don't have to be, but usually this is pretty typical as well. I have a quote here from Gartner. I think everyone knows who Gartner is. What this basically says is, if the user experience is poor, the productivity of the user will go down. That's what this super long quote basically means. If your end user experience is not good, the users will fight against it. They'll waste time with the solution. They'll be frustrated and ultimately lower productivity. So when we talk about enhancing worker productivity and the user experience, especially for remote workers, which most of us have been largely remote here, obviously, for the last several years, ensuring not only that the security is very high, but that the end user experience is excellent is super important, because otherwise your users will go find something else to do with their time. All right, so how do these solutions work? This is a simple picture from far away. It doesn't matter. You have your user on the left who's maybe at home or here or in the coffee shop that vendors like to pretend all of our customers sit at all day. And they're accessing on the far right their applications. The internet, SaaS applications like Google Drive, Office 365, whatever, and accessing private applications. Now, most of us here, when we access private applications, when we're not at the office, what do? We use some kind of VPN, right? You have a VPN client on your laptop, you open this thing up, you click connect, okay, I'm connected to the network like I'm on the Wi-Fi, and now I open my applications. Again, not zero trust. So what we're doing here is that remote workers connecting through a service. So in this example, I'm showing our Cisco service here, but we have many fine competitors that offer competing solutions, Zscaler and Palo Alto Networks and others, a service in the middle that is listening for these connections from the remote users and connecting them to the internet, SaaS, and private applications on the right. These ZTNA or ZTNA solutions are enforcing those least privileged access or zero trust policies in the middle. So when that user on the left is connecting to an application, they can only connect if they're authorized, right? Not they can connect to anything on the network like before or like with a VPN. So at the most basic layer, this is the way these ZTNA solutions work. Of course, with the optimization for a nice user experience. Now, there's basically three pieces. You have the user, you have the service in the middle, and I'm using this term called Security Service Edge. This is the industry term for these types of SaaS offerings that provide this connectivity, and you have your applications on the right. Now, we're here to talk about this protocol. So where does this come into play? Well, there's two pieces of this, and when we talked about that end user experience, we want the end user experience to be not just smooth, we like to say low friction, which means they don't have to spend a lot of time typing in usernames, passwords, and that type of thing. So the authentication and so on should be very nice. But when the user accesses their applications, this should feel fast, right? And fast with the internet's always a tricky term. What we mean by fast is with small delay. When they launch an application, immediately it starts working. We've all had the experience, you go to visit a website or something. If the website is not loaded in 3 seconds, I lose interest. I'm probably closing it. So having that end user experience be fast or quick is important. And this new protocol we've been talking about, this is where it can play a significant enhancement. And it is called the QUIC protocol. Now there's another technology here on the right called MASK. This is a proxy technology, and I'll explain what this does here in a minute as well. So ZTNA solution, we have this QUIC protocol, which I haven't explained what it does yet. It's a kind of enhancement to the foundation of the internet using HTTP. And then we have a proxy protocol, which I'll describe here in a moment. So let's start with QUIC. What is it? So it sounds like it's an acronym, right? QUIC here. It's not. It's not an acronym. What it is effectively a kind of replacement for HTTP. So when you browse websites, you're typing HTTPS. Well, normally we don't have to type that anymore. The browser's doing it for you. And we visit websites. And this protocol, HTTP or HTTPS with encryption, that's what's acting as the transport for you to connect to your applications. QUIC is an upgrade to this. Instead of being based on TCP protocol, it's based upon UDP. And UDP, as most of you probably know, is much lower latency because it doesn't have so much back and forth communication. The TCP protocol that the web was built upon 40 years ago was constructed during a time when the internet was much less reliable and you had a lot of loss of traffic, packet loss, and so on. UDP takes advantage of the very, very reliable internet we all enjoy today globally, and it lowers the latency of these connections. Now, this was actually created by Google, or more specifically, YouTube. How many of you use YouTube on your phone, right? Probably most people here at some point. And if you notice, when you open YouTube on your phone and start a video, the video feels like it starts playing immediately. Like, how does that happen? If I click play on a video in Facebook or something, it feels like it takes several seconds. In the YouTube app, it's immediate. It's because of this protocol under the hood called QUIC, where it's handling all of the kind of negotiation between the client and the server very, very quickly with less steps. And in that picture I showed you of the user at home accessing a private application, I think you can see why this would be a big advantage. So why QUIC? Well, it's very fast, as we said. There's less talking back and forth, and I have a picture, I'll show this in a second. The other thing about this QUIC protocol, when users are mobile, like we are now, what happens when you move from one place to another? Even if you move inside of this building, you go from one Wi-Fi network to another, or if it's cellular, maybe from one cell tower to another. And what happens? Your IP address can change. Well, when your IP address changes and you're browsing the web, that causes a disruption. QUIC does not require this disruption. It can sustain the IP address changing of mobile devices. They also have a much better behavior for traffic that is partially lost between the client and the server. You have something here called no TCP meltdown. This is, if you want to Google this term later, you'll get a better description. Effectively what this means, when you use a TCP protocol to tunnel other applications and encryption that are also TCP, TCP has a retransmission process for when packets are lost. Well, when you tunnel TCP inside of TCP and you need retransmissions, it can cause this kind of meltdown where it becomes so slow the session has to restart, and it is an absolutely terrible end user experience. The other cool thing that QUIC can do, many devices, like our phones, they have two radios, right? You have cellular, or LTE, or 5G now, and you have Wi-Fi. Well, wouldn't it be nice if the 5G and the Wi-Fi, you could use them at the same time to have more bandwidth for your applications? QUIC enables this capability. So it's a very cool technology, and it also allows for, well, maybe the cellular radio has a little bit of packet loss, the Wi-Fi doesn't, but it's slower, etc. It makes the best efficient use of both. Now, I talked about that efficiency of latency. So we say QUIC is faster. Well, those of us in information security know that the packets on the internet all move at the same speed. So you can't have a faster connection. What you can have is less latency. And this is what QUIC provides, you see on the picture on the right, less back and forth communication. So again, this means more efficient experience, and it's a better end user experience. Google did some testing and promoting this protocol, of course, and found that the overwhelming majority of applications are much faster using this protocol. So why not use it for your ZTNA solutions? Now, I promised there was a second technology involved here that goes hand in hand with QUIC. That's why we're talking about it here, even though it wasn't in the title of my session. This one is called MASK. And might be thinking, is this one an acronym? Yeah, it is, and it's the most complicated acronym you'll hear in a month. Multiplexed Application Substrate over QUIC Encryption is what it stands for, which you will never remember 5 seconds after I tell you. So that's why we call it MASK. All MASK is, it's a special proxy that runs over QUIC. That's all you need to know. This is going through the IETF as a draft, and it is custom tailored to work very nicely over this QUIC protocol for providing the ability to access applications over this kind of tunnel through the proxy. And I don't know how many Apple users are here. Apple introduced a technology a while ago called Private Relay. It was a thing you could turn on your Apple devices that basically created privacy for all of your traffic, which we all like privacy. Well, how did it work? It used the MASK proxy with the QUIC protocol, and it sent all of your traffic up to Apple proxies with anonymization to give you privacy. So Apple adopted this technology first several years ago. Microsoft is also adopting this technology under the hood of Windows, by the way. So this MASK technology, it's a proxy made to work hand in hand with QUIC. And the nice thing about this, it provides privacy from the end user standpoint and also privacy for the application. So when we compare this back to our VPN experience, right, where we're clicking connect on our VPN clients, when you click connect on that VPN client, it's like your laptop is back at the office on the Wi-Fi. That's the kind of technologically speaking, that's the behavior. You have an IP address on the network. With MASK, you do not. You're going through a two-way proxy where you have privacy. You don't even know what the IP addresses of the applications are, and the network doesn't need to know your IP address either because of this proxy technology. Any applications can be tunneled over this MASK protocol, and it will fall back to TCP as the underlying transport if QUIC is blocked. A lot of our customers running firewalls from us or other vendors will sometimes block this protocol because they can't inspect it. Cisco firewalls can inspect it, by the way, but if it's blocked, this will still work. It will fall back to the TCP transport underneath it. So pretty important capability here. This is in the IETF draft. It's used by Apple and soon Microsoft, and we are using it, Cisco is using it in our ZTNA solution. So this is something that we feel will provide a lot of benefit here. When you use these two things together, which is what we've done with our ZTNA solution or ZTNA solution, it provides this very, very low friction, fast end user experience for accessing private applications. So I promised not a product pitch, but just using it as an example. Again, this is that same diagram I showed you earlier. The user on the left, accessing private and internet applications on the right through the service, the security service edge. That end user experience now is made faster and very efficient via this QUIC protocol, and the privacy of the user and the privacy of the network is made better because of this MASK proxy. They work hand in hand. Now, what else can we do with this QUIC protocol? Well, I mentioned that Apple is using this now, and one of the things that make it a bit slower for customers to adopt these ZTNA technologies is you always have to install some kind of special client on the workstation, the employee or the student, if it's a university, on the workstation. Because Apple has already adopted this technology in their operating system, we can actually integrate with that technology in the operating system and kind of use it for free to access instead of Apple private relay servers, we can use it to access our corporate proxies so that those Apple users can access private applications with zero trust, with no client. So this is something we don't have in market just yet, by the way, but this foundationally works with what's built into the Apple operating system. And this is what it looks like. You have your Apple device on the left with this kind of private relay function turned on. We need a little bit of configuration to live on the Apple device so it knows, hey, if you're going to my acme.com private resources, go to this proxy, and that Apple device will talk with the Cisco private application proxies and provide this access and this very, very fast end user experience with no VPN button and with very low latency with just what's built into the operating system. I did, by the way, prepare 2 small demos of this. I know it's a bit small. I'll explain what's happening here. So the first one is showing the enrollment. So a user, they only have to do this one time. They're going to go to a special website, log in with their corporate account, and we're performing a multi-factor authentication here where they'll get the push notification on their phone. That website is the Cisco Secure Access Service. It will push down a configuration to the device, and you see now it says connected in the middle of the iPhone. That's the only part of the demo you need to know. The green circle, connected. So the user is enrolled, this device is enrolled, and now automatically when this user accesses company resources, the iPhone knows which cloud proxy, in this case the Cisco proxy, to access those resources. All of the authentication, the zero trust controls, everything are handled automatically. No special software installed on the device. Now the second demo, this is an iPad now that was already enrolled. We're just showing what this looks like now. And not only web applications work, but you can see I'm accessing a shared drive on a Windows file server. And just like I'm connected to the network, except I'm remote. Any web applications, remote desktop here, we're accessing a remote desktop server automatically through the ZTNA service using the built-in QUIC and mask functionality built into the Apple operating system, except connecting up into Cisco's secure access service instead of to Apple private relay services. I think lastly here we show accessing some private web applications through the same service. So this was a real demo we recorded in our lab. As you can see, these applications, very, very low latency and a nice experience, and still with the full security controls that you would expect, with no special software installed on the endpoint. So, what is the takeaway of all this? All of our customers are looking at these ZTNA solutions because they want to improve the security of VPN usage today. But they also want to improve the end user experience, right? That behavior I described where, when you wake up in the morning and you open your laptop, well, the first thing I need to do is click the VPN connect button, log in, and now I can start working. Customers want that to go away. The end users want that to go away. So instead of figuring out, do I need to connect the VPN, or, oh no, this application is on the internet, I don't need to, everything should just work. The end user shouldn't care about how they're connecting. So as customers are going and looking at these ZTNA solutions, I would encourage you first to talk to all the vendors, Cisco competitors as well. There's several here. Listen and learn about their solutions and ask, how are you ensuring a kind of an excellent end user experience, and are you using QUIC today? Of course, I'm suggesting you do this. None of them are except us, but we do feel this will be the future of these solutions, using this QUIC technology to not only improve the end user experience, but also improve the customer experience deploying things like clients and so on to make this much easier. We do have in the Cisco booth here, I think it's right behind us here over your right shoulder, Sylvan and Alex and myself happy to do demos of this technology and answer any technical questions as well. And I know I think I have a few minutes extra early. If there are any questions here, you can step up to the microphone and I'll answer them. Or if you would prefer to speak privately when we're done, I'm happy to do that as well. But that's what I had for you today. So hopefully it wasn't too technical for this kind of big audience and the small screens. But I really appreciate the time you gave me today. So thank you very much. The speaker's not working. Okay.
Okay.
There it is.
You mentioned that QUIC was built into the iOS, and you mentioned that Microsoft was looking towards that.
Yes.
But does it mean that all of the QUIC features that you talked about are only available on iOS right now, and we need to wait on Microsoft to get there?
So great question. So in terms of connecting, sorry, yeah.
Sorry.
You got it now. Okay.
Do that again.
Yeah. So for Microsoft operating systems using our solution, you would just require our client, our secure client, which then provides that QUIC functionality. At such time Microsoft integrates this technology into Windows 11, then there would be use cases where our client is no longer required. But it works today on Microsoft 11 with the Cisco client, absolutely.
Right. Do we have a roadmap from Microsoft's standpoint for the QUIC support?
I won't speak to that because I don't work for Microsoft.
Yeah, right.
Coming is what I would tell you.
Thank you.
Thank you.
No, just I have a question related to other OS system.
Mm-hmm.
That we need to install agent in desktop or on the server like Linux or
Yeah, good.
Ubuntu.
Yeah, good question. So I'll repeat the question. What about other operating systems? Do I need an agent? Don't I need an agent? That kind of thing. So today's talk was about this protocol QUIC and mask. And while the Apple devices, Apple operating systems have this protocol included, today to use Cisco's security service edge solution, the client is required because the client handles other things as well, like visibility and end user troubleshooting and so on. So we have clients for Windows, Mac, and Linux, and then we can natively support connectivity from Apple iOS and Android as well without a client, effectively. Okay.
When we are speaking about the client Windows,
Yeah.
Windows Server or only Windows the desktop?
Great question. So this technology and these ZTNA solutions are designed to provide connectivity from users to applications. So while in theory you can install these clients on Windows Server, it's meant for Windows 10 and Windows 11 that are end user operating system servers. If you have server services that need to participate and connect to these, they don't require a client. We would connect them in a different way, basically, that doesn't need the client. But this is very much an end user technology space for ZTNA. Hopefully that makes sense.
Sorry, another question?
Yeah, sure. There's nobody behind you, so have at it.
I would like to know.
Last one, yep. Yeah, last one. Please continue, yeah.
Okay. How you authenticate the users?
Oh boy, so I tell you, that's not a short answer. I'm at time. Why don't I come down and we can chat one-on-one if that's okay. Thank you.